Lots. 31, that's why it's worth 2 points of the 4 points of your homework. All right? Now, you are going to have to find the length of AE. You're going to have to find the length of EF. You're going to have to find the length of FG. You're going to have to find the length of GA. That's that big rectangle, square looking thing. Then you're going to find the length of BC. You're going to find the length of CD. You're going to find the length of DA. And you're going to find the length of AB. All right, and if you recall, that is the distance formula, which is x2 take away x1, quantity squared, plus y2 take away y1, quantity squared. Then the angles, yeah, you did have to do that problem. No, they're slanted. You can't figure out that that's 2 or that's 4. No, you can't. No. Do the distance formula. All your answers you're just going to see are different. All right. Those angles look to be like 90 degrees, so now you need to find the slope of AE. You need to find the slope of EF. You need to find the slope of FG. And do you see my notation? This helps you keep track of which slope is which. Slope of GA, you need to find the slope of BC. You need to find the slope of CD. You need to find the slope of DA. And you need to find the slope of AB. And the slope formula is y2 take away y1 over x2 take away x1. This was in the range of everybody's ability. All right, that's the division line. That's the big one, that's the little one. Now, if you want right angles, what must the lines be? The lines would be what? Perpendicular. And what do you know about perpendicular slopes? They're opposite reciprocals. So if you've got 2 of these that are opposite reciprocals, that means they're perpendicular. That would mean AEF is a right angle. So that's as far as I'm going on that one. It's your turn. I don't have time to do all that work. Yes, sir. 37. I liked 37. 37 is one of my favorites. All right, first of all, one of the things I want you to notice is they gave you the correspondence. What do I mean by that? They gave you the 2 triangles, but do you agree that they were not in, they were rotated? Okay, so that makes a problem a little bit more difficult to see. This is what I mean. They gave you the correspondence. So if we do this triangle, if we do WLJ over QBV, then what you should do is you should get everything from that first triangle. So that would be x plus 6. Then you've got x, and you've got x, because those 2 sides are congruent. Now, we're going to do QBV, but the question is what matches x plus 6? X plus 6 is WJ, so you've got to find QV. So if I look at QV, QV is 8. Then the first x is WL, this is WL. WL are the first 2, which means I need QB. QB is marked as 5. And then if I do the last ones, it's 5. That's a repeat, so where are we going to focus? Right here. And what do you do from here? So you're going to have 8x is equal to 5 times x plus 6, and you finish from there. Sides are in proportion. Cross multiply. Oh, now you distribute, yes. Yes. Next question. Mackenzie. 21. All right, on 21, we have space allowed for the mascot on a school's web page is 120 pixels wide by 90 pixels high. The nice thing about this problem compared to the ones that I did yesterday is that they're all in the same unit. There's no changing of units. This is number 21. Now on this one, we start large and we go small. Okay? So they told us, and you got to pay attention to width and length because I didn't. So we're 120 wide and we are 90 high. So that's what we need to be, by the way. That is the computer screen. The picture we have is 500 pixels wide and 375 pixels wide. So we're going to start with, this is our original. We're going to start with our original. We're going to go with our smallest side. So what does 375 correspond to in the smaller one? 90. And so now I'm going to have 500 over x. And then you solve that proportion, and that x had better be smaller than 120. That means then you can shrink it down perfectly. Okay? Because normally it doesn't work that way. Usually it's smaller. Okay, next. Yes, 22. 22 is more like the examples I did yesterday. This time we're starting with something small, and we're going to go to something big. But unlike first period, this period I'm going to pay attention to length and width. On 22, they say the mural is 16 inches wide, and it is 9 inches tall. And on this, then it said it's 24 feet wide, and it is 14 feet tall. Now, what's the issue here? All right, so we have to take 14 feet and change it to inches, correct? And that's going to be 168. So this is 168 inches. Then we're going to take our 24 feet, and we've got 12 inches over 1 foot. Our feet cancel. And that's going to be 288. So it's important that you know where your original is. So what's our smallest on the original? 9 is to 168 as, wait a minute, 16. Since I started here, I've got to use this one is to, let's make sure this works. 9x equals, what's 16 times, what is it? 2,688. Now what do we do? Does it fit? What is it? 299. So what's wrong? It's too big. No, so that means that instead of starting with 9, what are we going to work with? 16. Okay, so let's redo this. So we've got 16 is to what? 288 as 9 is to x. So this is going to be 16x. What's 9 times 288? 9 times 288? Somebody. Who's got Brian, you got a calculator?
No one's ever did. 9 times 2. 25,632.
Try that again.
9 times what number?
2.
2. Yeah.
Better. 2592. Now divide by 16. 162. Now, is that within our limit? Okay. So on these problems, you've got to double check and make sure you're within that limit. If not, then you've got to start with the other dimension. Okay? Any other questions? I did 37. Any other questions? Well, you should be watching as I do things, right? I don't know where I did it. I really did do it. Is that it? No, right there it is. Yes. Number 32, it says the Davis family is planning to drive from San Antonio, and they want to drive to Houston. How far will they have to drive? How can you find the distance between the two cities on the map? So how can you find the distance between the two cities on the map? What would you have to do? You'd have to get a centimeter ruler and do what? You'd have to measure it on the map, centimeters. Okay? Once you get the distance on the map, then you're going to take your scale, which is 1 centimeter over 112 kilometers, is equal to whatever you got by measuring on the map, okay, is to the actual distance, and then you do the proportion. So this is the proportion that you would solve. My guess is they expected you to take a centimeter ruler and measure that distance. Did anybody do that? Well, you have to do, well, it's going to be a guesstimate. Did it? Seriously? Okay, so we said it's 3 centimeters. So then you're going to say x is equal to 3 times 112, which is 336 kilometers. All right. Any other questions? Tonight's homework is 822, and it's section 7.3. So we are on 7.3. I do think, don't you like that warm-up, that EOC? Where I give you everything, you just have to match it and put it in the right order? Yesterday's number 2 EOC? Yes, I went through that yesterday. It was on the notes. I didn't do it for you, but I went through it. All right, now, let's come back over here. First of all, do I have any space? No, maybe. Yes, now we're doing notes. I want to remember definition. When you leave, you're going to leave your homework on this desk as you exit, unless we finish early. This is 7.3. Definition of similar figures. Definition of similar figures, if you want to get out your major geometry terms, has 2 components to it. What must be true? So the corresponding angles, that's not the F formed by parallel lines, are congruent. And then what's the second part? Sides are in proportion. All right, we are not working in congruence, we're working in similarity. Okay? So whenever you see an angle, it's referring to congruence, and whenever you see sides, it's referring to proportion. This is old stuff. This should have been in 7.2 notes. But I want to bring this back to the forefront of our minds, because what we're going to do, you know how in the past we've had to show that all corresponding angles were congruent and all the sides were in proportion? We're going to come up with some shortcuts for triangles. So we're back into triangles. So we did not do this investigation. All right, so the first investigation we would have done is called angle, angle, and now we're going to do a little similar figure. And what this says is it says if 2 angles of one triangle are, what should the relationship be? Congruent to 2 angles of another triangle. If 2 angles of one triangle are congruent to 2 angles of another triangle, the triangles are similar. Because we're talking about 2 angles of one and 2 angles of the other. We're going to talk about this a little bit more. If you know this angle is congruent to that one, and that angle is congruent to this one, do you know anything at all about these top angles? What? Okay, why? All right, the sum of all 3 is 180, and do you agree that that sum and that sum will be the same? So when you subtract from 180, those have to be what? Congruent. Remember our failed angle, angle, angle? All right, angle, angle, angle gives you similar figures. However, why don't we have to do the third angle? If you've got 2 of them, you know the third one's going to be what? Congruent. Remember when you did that investigation, you were shocked that that third angle was equal to the third angle you hadn't used? All right, so that's why it's called angle, angle rather than angle, angle, angle.
Would it also be like third
Vertex? What do you mean?
It's like those two congruent angles show that you go up vertex, so it's same with the other triangle.
Okay, these two angles aren't congruent themselves, so that doesn't make it isosceles. If you have two congruent angles here and two congruent angles there, their sum will be the same. Then the sum of these angles are 180. So when you subtract from 180, does it force those to be congruent? So when you do angle, angle, it's actually angle, angle, angle similarity. Okay? But we don't have to do angle, 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 but why? Because two angles force that third angle to be congruent. Investigation number 2 is side, side, side. Now look, you've got to put the little similar figure, otherwise you're speaking congruence. This says if 3 sides of one triangle are, what's the relationship on sides? In proportion to 3 sides of another triangle, then triangles are similar. So with side, 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 we need to know nothing about the angles. The angles will automatically be congruent. All right. The third one that we have is called side angle side similarity. What's going to be true about the two sides? No, they're in proportion. What's going to be true about the angle? It's going to be congruent. So what this says is if two sides of one triangle are in proportion to two sides of another triangle, and the included angle, that's the one between the two sides, and the included angles are what? Congruent. Then triangles are similar. So you got two angles or two sides in proportion, and the angle in between them congruent. You got side angle side similarity. Yes, ma'am. Okay. So those are your 3. You don't have 5 of them like you did in congruence. So part of your homework is to be given a diagram and to be able to state, are they similar and why? And your why is going to be one of these 3 reasons. Now, you can use a process of elimination and some common sense. If you're given a figure with absolutely nothing on any of the sides, what can you eliminate? Side, side, side? Anything else? Side, angle, side. If you're given a figure with nothing, no information about any side, what can you eliminate? And? Because if you know nothing about the sides, you can't show they're in proportion. You'd be looking at angle, angle. What if you're given 2 figures and you're given absolutely no angles? You're looking at side, side, side. Why will this not work? It has an angle. Now, what if you're given a combination of sides and angles? What will probably be your reason? So here we go. So, are these 2 triangles similar? So, we've got angle, angle. We've got side, angle, side. And we've got side, side, side. Okay, what do you notice? They have the same angle. So at that point, I'm given a single angle. What am I thinking right now? Well, not congruent, but which of these do you think I'm leaning towards? I'm going to be leaning towards this one, but that means I have to be given information on the sides of that angle. Am I? I've been given 12, and I've been given 15. Is that angle between those? I've been given 8, and I've been given what? 10. So I definitely have, why can't it be side, 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 even though I'm given this side? Because there's an X, exactly. All right, so now,
So it has to have all of them.
it has to have numbers on all of them for side, side, side. So if I look at this, I have my angle. How do I show the sides are in proportion? What do I have to do? I have to set up a ratio. 12 equals, if I have 12 on the top, what else goes on top? 15. So I did big, big on top. Now, what's the little one that corresponds to 12? And what's the little one that corresponds to 10? Oh, just kidding. I meant 15. All right. This is not good enough. If you leave this, that doesn't show me you understand. What divides 12 and 8? 4 goes into 12 and into 8. Okay, what divides 15 and 10? 5 divides 15 and 10. Now have you shown that they are in proportion? So the triangles are similar by side, angle, side, similarity. Now if they ask you to write a similarity statement, what that means is, just like in congruence, if I say triangle CAB, CAB, be careful, what would you say? To what triangle? FDE. All right, and that would be by side, angle, side. If the triangles are similar, can you now find X?
Yeah.
So notice we did big to little. My scale factor is 3/2. So if I did big, what's the big one I have not used? 14, and what is the little one? So now you're going to say 3x equals 28, or x equals, it does matter how you set it up. Okay, so maybe what we should have done is in the beginning, we should have just gone ahead and done 14 over x so we would be ready. Now, what transformation or combination would map this triangle onto that triangle? Dilation, okay, followed, that's not going to be enough, followed by a slide, which is by a translation. Are the orientation of the vertices the same? How do you know? You look at CAB, that is clockwise, FDE, that is clockwise. Rotation does preserve that. But if you notice, A and D and B and E and C and F correspond, so it's a matter of just sliding it over. All right, now, let's look at this one. Again, are they similar? Your choices, angle, angle similarity, side, angle, side similarity, and side, side, side. Is there one you can definitely eliminate? Why? Well, okay, there's already an angle marked. What else can you eliminate? Why? Do you have any information on sides? So it knocks out both of those. However, angle, angle requires 2 of them. Vertical. Do we have it?
Yeah.
All right, so then we're going to say triangle HKG is similar, what to what triangle? M. Okay, what's the reason? Angle, angle, similarity. All right, so what's required to move one onto the other? A rotation, is that it? Followed by a dilation. Okay, do you think the EOC is going to be concerned about that, you're understanding that? So what's happening is we're bringing in our transformation unit into our what? Similarity unit, all right? And dilations produce similar figures. So that's where that key, that connection is, if you want to put the pieces of the puzzle together. So do you think these are going to be easy? I mean, if you're given angles and no sides, it can't be any of the ones with sides. If you're given all sides and no angles, it has to be side, side, side. But make sure that the ratios work. All right, so now we are going to do a proof, except this doesn't make sense. Angle G is congruent to angle K. So that's our given. So what we're going to do is we're going to mark FG congruent to GH, which is kind of weird, isn't it? It's in the same figure. Then JK is congruent to KL, which is weird because it's in the same figure. Because usually we have one here and one there, one there, and one there. Remember? But you'll see how this works. And we're given G is congruent to K. Looking at those, what similarity statement do you think you're going to be using? Side angle side. So the first thing, now, it's not going to be as sweet as doing this for, similarity deal, because our sides have to be linked together for the proportion. So the first thing we're going to do is we're going to state that FG is congruent to GH, and we're going to do JK is congruent to KL, and that's given. So let's deal with sides. What should the sides be in? I just did the given. Okay. Sides are in what on similar figures? Sides are in proportion. They are not congruent. So FG in the bottom triangle corresponds to what in the upper triangle? JK. And then GH in the bottom corresponds to what? KL. Are those equal? Okay. Now, first period didn't see it. So if I told you this was 10, what is this? If I told you this was 5, what is this? Do you agree if I do FG over KJ and I do GH over KL, are those equal? Yes. Well, but they're marked. No, you don't need the 10 and 5. If these two are congruent and those two are congruent, when you put them in a ratio, you're going to have single over double, single over double. It has to be congruent. I mean, it has to be in proportion. Oh, did I mess it up? Where? Here? That's an L. Okay. Well, GH J is KL, FG, JK. Why? Sides are in proportion. I think. I don't know what they said in the textbook. And I don't think they did one with that. Okay, so now what do we know besides that? Angle G is congruent to what? Angle K, and that is given. Now, are these two triangles similar now? Have we shown the sides are in proportion?
Yeah.
Have we shown the angles congruent? So triangle FGH is going to be similar to triangle JKLY. Side, angle, side, similarity. No, that's an angle. Is that better? That's sometimes why we put that little arc there, so you distinguish the angles from the L's. So now let's do another one. We're going back to, there might be a couple. Not a lot, though. Not like the congruent triangle chapter. The parallel line and the congruent triangle chapters are the most heavy proof chapters. We're done. We've done it. All right, now, I'm crossing this out because we don't need this. Okay, crossing it out. If you're given two parallel lines, what kind of angles are you supposed to look for? Alternate interior? Corresponding? Same side? Alternate exterior. Question is, what kind do we have? Okay, if I trace this, and I trace this, and I trace this, do we have a Z? Okay, so what do we know about those two angles? They are congruent. Okay? Have we been given any sides? No. So what must this be? Angle, angle, which I have one pair. Where's another pair? Okay, so we've got vertical angles. Could you have done yet another pair? Could you have done your Z this way? So we're going to do vertical because that's what we've got. So now we're going to say that we've been given PR parallel to EM, and that was given. Now, are there one, so when I go to do angle R,
Wait,
yes,
wouldn't it be PR and
well, isn't R, P, and EM the same? See, I wrote R first, so I just flipped them both. Okay, angle R is congruent to what? Angle E. Why? If lines parallel, alternate interior angles congruent. How do we do the next pair? What do we have to do here? Angle, say it again. RIP is congruent to angle EIM. Nice corresponding of those. And why is that? Vertical what? Angles, not enough, are congruent. Not definition. If you look at your test, I busted you on that. So can we conclude now? Triangle PRI is similar to triangle MEIY. Angle, angle what? Similarity. Now you're going to like my next picture. So what we're going to is the whole reason for similar figures. Similar figures are used a lot. There's a man that was in the Vietnam War, and they use similar figures to figure out, maybe a height of something that they had to scale in order to get to the enemy. And they had, I don't know, they had some gizmo that they were able to look at a they had a pack of cigarettes, because that's something they had, and they stood that up, and they had some kind of instrument that could measure the distance from that to the pack of cigarettes and from that to the wall they were measuring. Well, could they easily measure the pack of cigarettes? So then they were able to use that information to find out how tall of whatever they needed. So watch this. So here's a boat and here's a little bear. Little bear wants to know how tall the boat is. Okay? They told us, do you like my picture? That little bear is 3.5 feet tall. And where's the shadow when the sun shines? Okay, is everybody aware the shadow's on the ground? When I taught trig, we had to go outside, because some people did not believe the shadow was on the ground. Honest to goodness.
where do they believe it was?
I don't know. I think they thought it was here. But anyway, how long is little bear's shadow?
3.5.
Nope,
No,
4 feet. Now, he can measure the ground from the boat. And actually, this is going to be the boat's what? Yes, that's the boat shadow. And what did he figure out the boat shadow was? 40 feet. Okay, what does he want to know? How tall the boat is. So I'm going to get a highlighter. He wants to know this height. So that's going to be B for boat. That's my variable. So we have a very large triangle. Oh, that's not what I wanted. We have a very large triangle. Do you see it? Okay, what else do we have? A very teeny tiny what? Look at little bear. He's got a little triangle. What angle? First of all, we're going to assume that this is perpendicular and little bear is also perpendicular to the ground. So there's one set of angles already congruent. What angle do those two pictures share? They don't share the right angle. They both have right angles, but I mean literally which angle?
By the bear.
The angle that is on the ground by the bear. Do you agree that this angle right here is in both the blue and the pink? So that's a reflexive angle. So these two triangles are similar by angle, angle. So the next question, and we'll let Hale answer this. Do you want to do boat to bear, or do you want to do bear to boat? Okay, Ethan? Okay, so this is what Hale has chosen, and this is how we're going to set up our proportion. So he's chosen bear, which means all bear dimensions will be where? On top. Now, the question is, what boat dimension matches 3.5? B. What boat dimension matches 4? 40. So now we're going to say 4B is equal to 3.5 times 40. We're going to do our number magic again today. All right? What multiplies to give you 40? 10 times 4. The 4 simplified. 10 times 3.5 is 35. I'm doing my number magic, so I don't need a calculator. Did you divide by 4? It should be, yeah, so you got it, right? What do you think of that problem? Like it? I just factored 40 and just simplified my 4s. 10 times 3.5 is easier to do than 40 times 3.5 divided by 4. I did number magic yesterday, too. I'll do it again. You ready? So, now, apparently, maybe he has to go to the bathroom. I don't know. Someone said he's doing a moonwalk. All right, before climbing this cliff, all right, Devin wants to know how high he's going to climb. He wants to know how tall this cliff is. And this is another way that researchers in the field can measure distance. It's called indirect measurement. This is a mirror. So he places the mirror on the ground, and then he starts to walk backwards with his eyes peeled to that mirror. Once he can see the top of the cliff in this mirror, he stops. So now, this distance is 4. He can measure. This distance is 50. He is 6. We need to know how tall the cliff is. One thing that you need to understand is, and this goes for pool also, when this angle right here, this is called the incoming angle. Let's say this was a pool table and you just hit your ball and it hit this buffer. The outgoing angle here are congruent. Did you know that? Incoming angle and outgoing angle are congruent. So when he looks in this mirror, once he sees the cliff, this angle is congruent to that angle. On a pool table. Yes, the same angle. That's how some people can figure out where to hit it. This is a 90-degree angle. This is a 90-degree angle. Why are these triangles similar? Angle, angle. So do you want to do little to big or big to little? So we're going to do big to little. So I'm going to take the big dimensions, which are 50 and what? C. What corresponds to 50? And what corresponds to C? C, 50 is horizontal, 4 is horizontal. C is vertical, 6 is vertical. So we have 4C is equal to 50 times what? 6. C is going to equal, what are the factors of 50? 5 times 10. What are the factors of 6? 3 times 2. What are the factors of 4? 2 times 2. Do you see how those 2 simplify? And is 10 a multiple of 2? Yeah. Well, how many times does 2 go into 10? What is 25 times 3, or 3/4? 75. My number magic without having to do the big multiplication or division. It's called working smart, not hard. Yes. Say that again. That's another one. Okay. So any questions? I believe that was my last slide. Did you like my pictures today? That bear and the boat, yeah, they were really cute.